Hello, hello, hello. So I hope you all are doing well. I got the next topic for you right here. It is similar triangles. So we did congruent triangles and congruency statements and all that stuff in the last two lessons. So now we're going to move on to similar. You would think it'd be a little bit easier, but unfortunately it's not. It's a little bit more difficult. There's some fractions and math that everyone hates doing. Let's jump right in and look at one of these. So we've got this right here. There we go, that'll work. We got these two triangles, and we want to find what's called a similarity statement. Similarity statement. Now, when we were doing congruency, we were finding congruency statements. This triangle is equal to, was congruent to this triangle. So you would have to put them in the right order. Well, that's what we're doing right here. We got to put them in the right order for the similarity statement. Similarity means that these two are the same triangle, but they're different sizes. There's a couple of ways to find similarity. If two angles are corresponding to two other angles, right, then they're similar. But I mean, there's a lot of ways, and they're not entirely important because it's not normally how they ask questions. Your questions are mostly focused on what is similarity in general. And similarity is the same triangle, but they're different sizes. Their angles are all the same, but their sides are different. We'll get to the math of the sides in the last two examples, but let's just figure out how to make a similarity statement. So when two things are equal, there's a little equal sign, right? And then when two things are congruent, you basically get this little squiggly, right, on top of the equal sign. That little squiggly means similar, which I just realized I need to go back through and redo on the entire quiz that I made because I put everything as congruent. Oh, crap. All right, I'll get that done. But yeah, the squiggly means similar. Oh man, I can't believe I made that mistake on that. I spent like 2 hours making that test and I did all of that. I'll go fix it later. Okay, well, aside from my mistakes, the squiggly means similar. So same exact triangle, different sizes. So we got to put this in order. So looking at this triangle, it's going to be very similar. These two are pretty easy, right? They look like they're in the exact same orientation, as in like, you know, this translate, like this just slid down and got smaller to become this one. So all we have to do is follow the same order. If I start here on this side, let me get my little spotlight. If I go right here to this side, right, this has no markings whatsoever. And I know that if I follow it along, it's the exact same way over here. If I go, all right, no marking, one marking, two markings, 0, 1, 2, 0, 1, 2. That's the exact same order. 0, 1, 2, right? This angle equals that one, this angle equals this one, which would imply that the missing one, the one you don't have, equals that one. So if I go from no markings to one marking to two markings, and I do the same order on the other triangle, then that's how I can set up the similarity statement to be true. So triangle, 0 markings is C, 1 marking is D, what in the world? So C, D, T, right? 0, 1, 2, C, D, T is similar to triangle. Go down here and do the exact same thing. 0, 1, 2, K, S, R. And that's it. That's a similarity statement. So the nice thing about this is just like the congruency statements, the order has to matter. The order is super important. But once you have this written out, you know that, well, CD, this side, corresponds to KS, this side. Sorry, my cats are messing with something. All right, so CD corresponds to KS. DT corresponds to SR. DT corresponds to SR. And then TC corresponds to RK. TC corresponds to RK. So that's going to be important when we start doing the math. You need to know which sides correspond with which. But until we get to the math part, let's enjoy the simple, easy stuff, right? Similarity statements, which is more than half your quiz, is just put them in the right order. Now, can that be harder? Oh, absolutely. Like number 2 here. They absolutely can be harder. So at first glance, you're like, oh, easy peasy, right? You know, like top, right, left, top, right. Wait a second. This top has 1 mark. This top has 2 marks. These two do not correspond. These are not the same angle. So wait, what? All right. So we need to figure this out. Similarity statement. So what we're going to do is figure out what corresponds to what. The starting triangle, basically, like the way you start this, it doesn't really matter so long as this one matches it. So whatever order you decide to do on the first one, you have to do that order on the second one. For instance, we could just do A, B, C, right? Go in order of the alphabet, A, B, C. But now we have to make sure we start at the right point, go to the right place, and end at the right place. So if I did A, B, C, I would start at the single notch or angle and move towards the side or move towards the angle without any notches, and then move to the one with 2. So it'd be 1, 0, 2, right? 1 notch or 1 marking, no markings, 2 markings, A, B, C. So then I would go 1 marking, no markings, 2 markings. I'd have to go G, D, F. Now I say have to because, I mean, well, you do it either way. You could make this triangle right here, you could label it anything. So for instance, we'll do what we just said. Triangle ABC is similar to triangle. Well, if I did 1 marking, no markings, 2, A, B, C, I'd have to start at G, go to D, and end at F. So GDF. So that's perfectly fine. That is a similarity statement. It's perfect. But to let you know, there's a bunch of ways you can write a similarity statement. If I did triangle ACB is similar to triangle, now I got to figure that out. ACB, right? I went from 1 marking to 2 markings to 0. So come over here. 1 marking, 2 markings, 0. GFD. GFD. Both of these are true. If you'll notice, the exact same things correspond. A corresponds to G, B to D, C to F. A to G, A to G. BD, BD. CF, CF. AB corresponds to GD. AB corresponds to GD. So no matter what you do, as long as you set it up correctly, all right, so long as you set it up correctly, it doesn't matter how you set up the first triangle, so long as the second one matches it in the same order. Same order. So that's the majority of your quiz. I mean, I think it's 7 questions, and 4 of them are just give me the similarity statement. As in, look at this triangle, look at this triangle, trace it around, figure out which one makes sense. But of course, being as how this is a math class, we have to do math sometimes. So now we get to talk about much more complicated concepts. Like, where's my little text? We need to figure out what a scale factor is and how to use it. So, oh man. Sorry, I just opened up my phone and saw a bunch of stuff. I'll look at that later. All right. So we got scale factor right here. The scale factor, if any of you have ever seen like a model or a model kit, you know, you'll get like, oh, it's the Eiffel Tower from Paris, and it's like this tiny little Eiffel Tower, and it's 1/1000th size. Well, that 1/1000th is a scale factor. If you took the tiny one you're holding and multiplied every single dimension by 1,000, then it would theoretically be the exact same size, make, and model of the real Eiffel Tower. So a scale factor is, you know, this is so much larger or so much smaller than this other thing. When we are looking at similar triangles, right, I said that they're the same triangle, different sizes. Well, that's the case here. These two triangles are the same triangle, but different sizes. And their sizes can be set up as a ratio or a scale factor. And you can use that to solve, well, for missing sides. So the way these questions only work is, number one, they tell you, they give you the similarity statement, like we have right here, right? They just give us our similarity statement. Triangle ATS. Oh, I did it again. That's supposed to be similar, not congruent. Oh, that's a pain in my butt. All right, I'll handle that later. But ATS is similar, not congruent, to DVP. ATS DVP. So we've got the way they set up, right? We got that all set up. Now we need to figure out how to solve for this missing side, this x feet. We got 21 feet and x feet, 7 feet and 10 feet. There are two ways to do this. The first way is to find the scale factor and then multiply by it. And we'll do that first, and then I'll show you an easier way, at least a way that I'm fairly certain is easier. But I gotta teach you the scale factor. I have to. That's part of the curriculum. So let's do this first. So the scale factor, how do you find it? All you're gonna do is set up a fraction of corresponding sides, which the similarity statement gives you, and then reduce the fraction. So I need to find a pair of sides in the small triangle and the big triangle that are corresponding, and I have a number on each. So for instance, like PD, if I go up here, PD, so the last letter and the first letter, SA. So PD corresponds to SA, 10 and X. Well, I don't know X, right? That's what I'm trying to figure out. So I can't use those two. They correspond, but I can't use it because I need two numbers there. So let's go over here, PV. All right, or VP, right? VP are the last two letters, so TS are the last two letters. Look at that. VP, TS, 7 and 21. So we've got something there. We can have 7, nope, other one, over, why is that red? I want it to be red. All right. 7 over 21. Oh, do I want to do that? Put the big one on top, which is a problem. I got to flip that. My bad. Now I'll explain that in right now. I'll explain it right now. So our x is on the big triangle. That's what we want to find. So that means we're going to go from small to big. Well, if you're going from small to big, then you put the large one, the big triangle, on top. You put its side on top. So scale factor from small to big, right? Small triangle to big triangle. Let's do select. This would be much easier on a whiteboard, just so you know. There we go. Okay, so scale factor, small to big. I'm going from the small to the large. Because I'm going from small to large, I want to put larger triangle side on top and the smaller triangle side on bottom. All right. So we've worked that out. Now we were already comparing 21 and 7, so the larger triangle side is 21. The smaller triangle side is 7. So we've got that set up. Now we reduce this fraction. Now, if you don't remember how to reduce fractions, it's fine. All you do is find a number that goes into both. I tend to try and stay really small. Like, all right, 2, 3, 4, are these numbers divisible by either one of those? Well, 21 is divisible by 3, right? It equals 7. 7 isn't divisible by 3, so we got to keep going. But you're not going to hit anything until you get 7. And 7 goes into 21, 7 goes into 7. So that's how we reduce it. Divide both of these by 7. Well, when we do that, we end up with 3, because 21 divided by 7 is 3 over 1. And anything over 1 will equal just the top number. So this is just 3. What that means is that this triangle, this large triangle, is 3 times larger than the smaller triangle. It's 3 times larger. Now, when it comes to the scale factor, you will always multiply by the scale factor. You will always multiply by the scale factor. Once you have it, you're going to use it to multiply. Now, our scale factor is from small to big, right? Well, we've got 10. We know that this side, this x, corresponds to 10, which makes it pretty easy. 10 times the scale factor. And our scale factor is 3. And that's going to equal 30 feet. Which means this guy right here equals 30 feet. So that was very long and complicated, right? I mean, it's really not. I can break it down much easier. I just had to get all of the vocab in there. But in all honesty, if you're missing a large side, find 2 corresponding sides on the triangles, put the larger triangle on top, reduce, and multiply what you have to get the answer. So that's how you use scale factor. That's how you find scale factor. You can use any 2 sides on the triangles that correspond to put them into a fraction and reduce the fraction, and that's a scale factor. But let me show you a much simpler way. Much simpler way. So you're going to use the similarity statement again. Absolutely going to use the similarity statement. I'm just going to set this up now so that I don't have to do it later. So you're going to use the similarity statement to find your corresponding sides. We already know that 7 corresponds to 21 and 10 corresponds to x. So now all you have to do is be consistent. Do we want to put the big one on top or the big one on bottom? Whatever your decision is, you stick with it. We're going to do it just like we did last time. So 21, right? We're going to put big over small. So 21 corresponds to 7. And then over here, we did big over small, so we need to do big, which is x, over small, which corresponds to 10, right? Cool. Well, if you remember any of your algebra, once you see 2 fractions and an equal sign in the middle, you can cross multiply and then divide. So we cross multiply. 7 times x is 7x. equals, and then 10 times 21 is going to be 210. And I said cross multiply, then divide, because, well, how do you solve 7x equals 210? Well, you divide both sides by what's attached to the x, which is 7, and you get x equals 30. That is much simpler, in my opinion. It is called a ratio. Having a fraction equal another fraction is a ratio. And I find it to be incredibly simpler than scale factor. I think you'll probably agree with me, but it depends. I mean, whichever way clicks for you is the way you should do it. You need to know how to get a scale factor. But if you notice right here, that's it, right? If you took this fraction and reduced it, you would have the scale factor. So both methods will get you there so long as you know where it is. But you set them up in a fraction, cross multiply, divide, and you're done. So let's do one more example of that. There are 3 questions on your quiz based on this. And then we'll be done. I do believe you guys will be just fine on doing this. So, oof, black background is going to be a problem. I do not have enough room to work on this, so let me make this guy. There we go. To work on. All right, so we have our, this is a congruency statement again. Man, I screwed that up. They're similar. They're supposed to be similar. We'll do the scale factor first. I mean, I know it seems like it's much harder, but I just want to make sure that we get this because I designed these questions that way. So, scale factor first. This time, though, our x is on the smaller triangle. So our scale factor is going from big to small, right? So we're going to flip it around a little bit. Since we're going from big to small, we're going to want the small side on top. Small side, or small triangle side over big triangle side. That's how we're going to set up our scale factors. Our scale factor, my brain just stopped working, fraction. We're going to do the small triangle side over the big triangle side. Now we just need to figure out the sides, right? We need to figure out what is corresponding that we both have numbers on. In the small triangle, we've got x. We're not using that, right? So let's go right over to the 15. R-E. R-E. So the first letter and the last letter, R-E. So come over here, H-G. First letter, last letter, H-G, 90. So we got 15 and 90. Boom. Small triangle is 15. Large triangle is 90. And now we reduce. Well, 3 goes into both, 5 goes into both, but I'm going to save you some time, and I do believe, if you're looking at it, 15 goes into both. 15 goes into 15 one time, right? And then 15 goes into 90 3 times. No, wait, 6 times. Oof, 6 times. I said that so confidently, too. I was so wrong. All right. So 15 over 90 can be reduced to 1 over 6, 1/6. And then remember, always multiply by scale factor. That's always what you do with the scale factor. You're always going to multiply by it. We already set this up to go from big to small. So we've got x here on RT. We need to find a side that corresponds to RT, first letter, second letter, RT, HB. HB, 36, corresponds to x. So it's 36 times 1 over 6. Let me write that out. Yeah. Cool. So you're multiplying 36 by 1 over 6. Remember what I taught you? I think I taught this to you. When you multiply a fraction by a whole number, you multiply by the top number and divide by the bottom. Yeah, I taught this to you. Yeah. All right. So 36. Oh, is that liberal arts? I don't know. I'm confused. I hope I taught it to you. If not, anytime you multiply a fraction by a whole number, multiply by the top number and divide by the bottom number. So 36 times 1 is 36. And then you divide by the bottom number, which is 6. So 36 divided by 6 is 6. And that's x. So that's how you would do this with the scale factor, right? Let's do it with the ratio real quick. Because, I mean, again, I do find it easier. I think you will too. Feel free to tell me I'm wrong, you know, if you think I'm wrong, but whatever. All right. So let's do our corresponding sides. Again, we can just set that up. We know 15 corresponds to 90. And I'm going to do it differently, right? Because when you do the ratio, it doesn't matter which one's on top so long as the other fraction has the same thing. So I'm going to flip it around. I'm going to do 90 over 15. Right? I went big over small. So now I need to go big over small. 36 over x. So then we cross multiply. 90x equals, I'm not gonna lie, I do not know 15 times 36 off the top of my head. So I'm gonna go 15 or not. What am I doing? 15 times 36, 540. There we go. Not what I wanted. There we go. All right. So you cross multiply, and then, you know, you divide. Divide by what's attached to the x. Divide both sides by that 90. You're going to end up with x equals 6. Easy peasy lemon squeezy. So ratio is significantly less steps. There's also less ways to mess up. I mean, you just, the big side over the small side equals big side over small side. Like, so long as you go big over small, then you get it right. Versus, you know, the scale factor, which can be confusing and mistakes can be made. I feel like the ratio is a much more reliable way of doing it. But regardless, do whichever way makes sense to you, do whichever way works for you, and you'll do just fine. I am going to go fix the entire quiz because they all say congruent instead of similar. I can't believe I did that. So this will get posted in a little bit after the making of this video. So I hope you all have a great day, and I will talk to you soon, hopefully. Don't forget to message me if you have any questions. You have a great one, and I'll talk to you later.